Hi, welcome to this tutorial on solving equations that have logs in them. And as you can see, I've written down 4 examples of equations then that have logs in them. Now when you're going to solve equations with logs, what you must always remember is that you must reduce them down to 2 terms. 2 terms. They'll either be this ending, the log of a number, let's say n in base a equals b, in which case if you've got an equation that is in this format, it follows that a to the power b equals n. That's the definition of a log. The other scenario that you could reduce a log equation down to is the log of a number, let's say n, in a given base a say, equals the log of another number, let's say m in base a. If that's the case, then it follows that n must equal m. So let's just highlight that result for you. So when you're doing any log equation, make sure you reduce it then down to 2 terms, either of this type or of this type. So let's get cracking then and look at equation number 1. Now in equation number 1 we've got 2 terms. We've got the log of something equals a number, just like this. So by the definition you can see that a is the 3, n is the x and b is the 2. So anti-logging it, that is removing the log, gives us this result. A to the power b equals n. So for this one it's going to be that x equals 3 to the power 2. X equals 3 squared, so therefore x is 9. Now in the next example, number 2, what I've got again is 2 terms. I've got the log of something, log of 27 in base x equals another number. So it's this type. And again you can see that a is x, n is 27 and b is 3. So if we anti-log this, removing the log, by this definition we've got a to the power b equals n. So in other words we have that 27 is equal to x cubed. To get x, I need to take the cube root of both sides. So x is equal to the cube root of 27. And the cube root of 27 is 3. So x equals 3. Now in example 3, what I've got now is still 2 terms, but in this particular example I have got the log of something equals the log of something else, both in the same base. Remember, this is base 10. Okay, by default, if you don't write anything down there against the logs, this is understood to be base 10. So what I've got is this particular scenario. The log of one number equals the log of another number. So therefore, if we anti-log, it implies that n equals m. So if I apply that rule here, it means that anti-logging gives 5x equals 2x plus 1. And this is a simple equation now, one that we should be familiar with. Just take 2x from both sides and that gives me 3x equals 1. And if I divide both sides now by 3, I'm left with x equals 1/3. Now in my final example, you can see that I have now got 3 terms. 1, 2, 3 terms. 2 terms are log terms. So therefore I've got to reduce this down to 2 terms. And the way I do this is to bring the logs to one side, gather the logs together. I'm going to remove this term from this side by subtracting it from both sides. And what that's going to give me is that 3 equals the log in base 2 of 5x plus 4, and then I subtract the log in base 2 of 2x minus 5. Now you should be familiar with the subtraction rule for logs. The subtraction rule for logs allows me to say that the log of one number minus the log of another number is the same as the log of one number divided by the other value, 2x minus 5. If you're not familiar with that rule, just go back on my website, look under tutorials for logs, and you'll find that I've done a tutorial on simplifying log expressions. Okay, on the basis that you've got that far, what we've now reduced our original equation to is two terms. We've now got a number and a log. So we've got this scenario over here. So by applying this rule, we can see that therefore 2, the base, to the power 3, 2 cubed in other words, will give 5x plus 4 over 2x minus 5. So we'll write that in, 5x plus 4 over 2x minus 5. Now 2 cubed we know is 8. And so if I multiply both sides now by 2x minus 5, I've got 8 multiplied by 2x minus 5 equals 5x plus 4. And we've got an easy equation now, so we should just carry on in the usual way, just expand the bracket. So we've got 16x minus 40 equals 5x plus 4. And if I now subtract 5x from both sides and add 40 to both sides, what I'm going to find that I get is 16x take 5x, which is 11x, equals, and then 4 plus the 40 is 44, and dividing both sides by 11 gives me x equals 4. Okay, so hopefully you've been able to follow the 4 examples. Remember then that when you have log equations, always reduce them down to two terms, either like this, the log of a number equals another number, or the log of one number equals the log of another number. And then you can anti-log and get either this result or this result. Okay, so assuming then you've been able to follow that, what I'm going to be showing you in my next tutorial is how we handle further equations with logs when the bases are not the same, when I mix up bases. Okay, like in this one we've got base 2 in both terms there, but I'll show you what happens if we handle an equation like this, which is in say base 2 here and in another base like base 3 here. Okay,